Welcome to our video on trigonometric ratios. Let's go ahead and take a look at example 1. Find the value for each trigonometric ratio. Notice we are being asked to find sine of theta, cosine of theta, and tangent of theta. The best way to remember these ones is through a mnemonic device, SOHCAHTOA, where SO stands for sine equals opposite over hypotenuse. Ca stands for cosine is equal to the adjacent divided by the hypotenuse, and tangent is equal to the opposite leg divided by the adjacent leg. Okay, that's why we call them ratios, because we're dividing two numbers. Okay, so let me go ahead and write those in here for you. Sine of theta is equal to the opposite over the hypotenuse, or the opposite leg, to be precise with our vocabulary, divided by the hypotenuse. Cosine of theta is equal to your adjacent leg divided by the hypotenuse. And tangent of theta is equal to your opposite leg divided by your adjacent leg. Okay, so let's take a look at the diagram. Okay, we're given our angle theta in here, and we need to label the parts. So always the leg across from it is what we refer to as the opposite leg. Okay, then the leg that we use to create that angle is what we refer to as the adjacent leg. And then the side across from it is what we refer to as the hypotenuse. Okay, now here it will be good if we can come up with the value for the length of the hypotenuse. And to do that, notice since we're dealing with the right triangle, we can use Pythagorean Theorem. So we would have a squared plus b squared is equal to c squared. Now c is always the length of your hypotenuse. So let me go ahead and call it x for now. Okay. Now here we'll have 12 squared plus 16 squared is equal to x squared. Okay, so we will need to come up with the actual squares of those numbers. Okay, we can just say, well, 12 squared is equal to 144 plus 16 squared is equal to 16 times 16, which happens to be 256, and that's equal to x squared. In other words, we have that 400 is equal to x squared. Okay, now how do we get x by itself? Well, we simply know that we can take the square root on both sides, and that will tell you that x is equal to plus or minus 20. Okay, now since we're dealing with lengths, and lengths cannot be negative, we're going to take the positive 20 here. So the value for x is equal to 20. Okay, now with that value given to us, we can go ahead and figure out what are the values for your trigonometric ratios. Sine, it's really your opposite leg divided by your hypotenuse. So the value for the opposite leg here is 16, and the value for your hypotenuse is 20. Notice we can find the greatest common factor of 16 and 20, which is 4. Okay, that's your greatest common factor or greatest common divisor. And 16 divided by 4 will give you 4, so that's 4. And 20 divided by 4 is 5. So sine of theta, it's really 4/5. Okay? In a similar way, we can find cosine. Cosine is the length of the adjacent leg divided by the length of the hypotenuse. The adjacent length in this particular right triangle measures 12 units, so let me go ahead and write that in there. The hypotenuse measures 20. Now once you have that ratio, let's go ahead and find the greatest common factor of both 12 and 20. In this case, that also happens to be 4, so let me divide by 4. And 12 divided by 4 will give you 3. 20 divided by 4 will give you 5. Therefore, cosine of theta is just 3/5. Lastly, we can figure out what is the value for tangent of theta. Tangent of theta, it's opposite leg divided by adjacent leg. So the measure for your opposite leg is 16, and the measure for your adjacent leg is 12. We search for the greatest common factor here for 16 and 12. Again, that happens to be 4. Let me divide by 4 here. 16 divided by 4 is 4, and 12 divided by 4 is 3. So tangent of theta is 4/3. Okay, so notice here in this particular problem, it was critical that we knew the definition for our trigonometric ratios, okay, where SOHCAHTOA can really help in there. And we also needed to figure out the length for the missing side through the use of Pythagorean Theorem, okay. Once you do that, it's just a matter of substituting values in and simplifying those fractions to get the trigonometric ratios of interest, okay. Now let's go ahead and take a look at one more example here. Okay, example 2. Find the value for each trigonometric ratio. One more time, let's go ahead and circle our angle theta here. I'm going to label my parts based on that. So here, this will be my opposite leg. This one will be my adjacent leg. And notice, one more time here, I'm missing my hypotenuse. So I'm going to go ahead and call it x in here. I'm going to figure out that value based on Pythagorean Theorem. So I'm going to write here a squared plus b squared is equal to c squared. Now, using Pythagorean Theorem, the legs, the order for them don't really matter, or doesn't matter. So we can go ahead and say, well, we have 15 squared plus 20 squared is equal to x squared, okay? That's just based on Pythagorean Theorem, okay? Just based on Pythagorean Theorem. So now what? Well, we need to square the 15. So what is 15 times 15? We know that's just simply 225 plus 20 squared, and 20 squared is simply 400. That's equal to x squared, okay? So we can add this two together. We have 225 plus 400. That will give you 625 is equal to your x squared. Okay. Now, how do we actually simplify this, or how do we get x by itself? Okay, that's a big question here. How do we get the x by itself? Well, it's being squared. So in order to undo a square, we simply do the following. Okay, we just take the square root. So let me take the square root here, and whatever I do to one side, I'm going to take it to the other, or do it to the other. So in this case, I have that x is equal to plus or minus 25. And since we're actually doing lengths, we're going to take the positive value. So x is really 25 here. Okay? So you ask me, what is sine of theta? Well, sine of theta is the opposite divided by the hypotenuse. I can just tell you the opposite leg measures 15 divided by the 25, which is the length of the hypotenuse. We find the greatest common factor here, which happens to be 5. So this is just 3/5. Okay, so let me record it up here for you. This sine of theta is just 3/5. Okay, in a similar fashion, we have cosine of theta is equal to the length of the adjacent leg divided by the hypotenuse. So we have 20 divided by 25. Let's go ahead and find out what is the greatest common factor of 20 and 25, which happens to be 5. So 20 divided by 5 is 4. And 25 divided by 5 is 5. So cosine of theta is 4/5. And last but not least, tangent of theta is the ratio relating opposite divided by adjacent. So we have 15 divided by 20. We find the greatest common factor, which happens to be 5 as well. Okay, and this will be really 15 divided by 5, which is 3, and 20 divided by 5, which is 4. So this is 3/4. Okay. So that concludes this particular tutorial on how to find trigonometric ratios. Just be careful, use Pythagorean Theorem if needed, And good luck. Enjoy your homework tonight.